Hello, and welcome back to Professor Caustic, the YouTube channel, the, you know, very professional YouTube channel. So today, I was on Instagram, and I saw this really cool integral problem. Not very complex, but cool enough to be featured in a video. So I'm in a new location, I'm all set up, and we're gonna take a crack at this integral. But the first thing, we're gonna use two approaches to solve it. The first one will be using an identity we're also going to prove that I find very interesting. So let's look at that identity. The first thing we'll do is actually, state the identity. So let's suppose a limit is in the form the limit as x approaches a, f to the g. And so suppose it's in this form. Obviously, we have a function f and our function g. We don't necessarily need to analyze the domain or range. Then we can say, actually that's but we can say this is equal to e to the limit as x approaches a, f minus 1 times g. And honestly, that's a pretty neat identity. That's why I wanted to, take a peek at this integral problem, which I'll show in a little bit. But yeah, I feel like that's pretty neat. So let's prove that. So we're gonna look at the proof. So the first thing we're gonna do is obviously start out with the initial condition, which is the limit as x approaches a, f to the g. Now we're gonna rewrite this as the limit as x approaches a of we'll do 1 plus f minus 1 all to the g. And clearly this is mathematically sound as 1 minus 1 is equal to 0, and we're just left with the original f to the g. So that's good. Now, what we're going to try to do right here is we know that, do a little note on the side. We know that the limit as x approaches limit as x approaches. Why am I blanking on that? I'm going to say infinity for now. That might be wrong. 1 plus 1 over n to the n is equal to e. I guess we should say n. Yeah, infinity. That's right. We know that this is that. And, doing a little bit of maybe cheating in a sense, but, a little deductive reasoning, we know that we want to try to get an e. So we're going to try to approach this, what we just created, and we're going to try to get, something in the form of 1 plus 1 over n all to the power n, because our goal is to get an e. So what we can do first is, well, here we have a 1, and then we have a plus something, and here we have a 1, and we have a plus something. So let's rewrite that slightly, and we can say that the limit as x approaches a, 1 plus 1 over f minus 1. That's a bit of a mouthful, but it's not too bad. And we can see that now, well, we're all the closer to this, the nice e limit. What we could do then is multiply by f minus 1 over f minus 1, which of course is 1, so it's mathematically sound and helps with our manipulation a little bit. So then we'll just rearrange terms. I'll add a little bit of square bracket, 1 over f minus 1. Yep, and this, and then we're going to say this is 1 over f minus 1, and then we have g times f minus 1. So clearly you can see that this is actually going to reduce 2e, and if I guess if you wanted to, you can replace this 1 minus f minus 1 with like 1 over f minus 1 with like an n or something. Doesn't really matter. And you would pretty clearly see this in the form. But we will see that this is e. Move the limit over to the limit as the limit as x approaches a, g to the f minus 1. G times f minus 1. And that is pretty neat. And then, so that's the proof. It's very short, especially if you know the direction you're going in. But one thing I forgot to note is that this is only valid when it's in the form 1 to infinity. So, obviously that would mean the limit as x approaches a of f would simplify to 1, and the limit as x approaches a of g would be infinity. Then you can say this. So that's an important contingency that I kind of got too excited and glossed over. But now I'll show you the cool integral. I'll write it on this page and then we'll move to another one. So the integral that I found on Instagram, limit as x approaches pi fourths. So let's give you a hint, that's going to be trigonometric, of tangent x to the tangent 2x. And, kind of seems like a mouthful, but it's not that bad. It could be worse. Anyway, so what we're going to do is, I'm just going to copy that. So this will be our approach number 1. Because we can use this, the form we just created, our little identity, or we can kind of just approach it trigonometrically. So we will say that, okay. So we'll start here. Then we're going to use this form, and we'll say that e to the limit x approaches pi fourths of tangent x minus 1, that's our f, f and g, times tangent 2x. So now we can see that this is a tangent x and this is a tangent 2x, so we don't really want that. So we're going to use a half angle substitution in order to reduce that tangent 2x to something with a just tangent x. Keep it in terms of tangent x instead of tangent 2x. So let's keep this as tangent x minus 1, and we'll change this to 2 tangent x over 1 minus tangent squared x. So clearly we see that's successful. That's just a basic identity. And now we'll just do some simplification on this one. So we'll have e to the limit x approaches pi fourths, and I will just, what do I want to do? Yeah, so first I will just expand the bottom. So it'll be, I'll expand, I'll condense everything first. So 2 tangent x, but then over this, what I was hinting at, we'll expand this bottom. So it'll be 1 plus tangent x, 1 minus tangent x. And that doesn't cancel out directly, but if we add a negative sign to this, then the signs will switch. So now we can cross it out. The negative sign there too. So these cross out, and we're left with e to the limit x approaches pi fourths of negative 2 tangent x over 1 plus tangent x. Did that a little sloppy, because remember this is supposed to be, a raised to a power. And now we'll just plug it in. So tangent pi fourths is equal to 1. So we're going to be essentially just at negative 2 over 1 plus 1, which is negative 1. And that actually solves our integral. Oh, I suppose I call this video integrals. That's not true. This is a problem. That's my bad. This solves the limit, which the answer is 1 over e. And that's a neat solution to a little bit of a complex or seemingly complex limit, not integral. My bad. Now we're going to look at approach 2. And this one is more, just trigonometric. We don't need any fancy, we don't need any fancy identities. So I'm just rewriting the integral. Oh my God, I'm rewriting the limit now. And the cool thing about this one is we're going to use our natural log tool, and what we're going to do is set this limit equal to y, and then we're going to take the natural log of both sides. And the reason why you would think of taking natural log is obviously we're raised to a power, and using just the fundamental rules of a natural log, it works very nicely. So we're going to have the limit as x approaches pi fourths of tangent 2x times ln tangent x. And I kind of reduced some steps, but that's where you end up. And you might be like, oh, where do I go from there? And it's a little tricky, but what we're going to do is rewrite this so we can get a 0 over 0 and use L'Hopital's rule. So we're going to have limit as x approaches pi fourths. And then the easiest way to do this would just be to make the tangent 1 over cotangent. So we'll have ln tangent x over cotangent 2x. And now we can see that this is going to be 0 over 0. And because of 0 over 0, we can use L'Hopital's rule. 0, 0, 0, L'Hopital. Oh, wait, no. It's over the O, I think. Actually, I have no idea. It's my bad. Okay. And then from there, we are going to do, well, I mean, obviously, we're going to apply L'Hopital's rule, so we're going to differentiate the top and the bottom. L'Hopital's rule is really a godsend. So we get 1 over tangent x, because that is the the initial thing, because ln would be 1 over x, and then our x is just tangent. Then we differentiate tangent x, and we're going to get secant squared x. Now we differentiate cotangent x, which would be negative cosecant squared 2x, and then obviously we use the chain rule, and we'll actually have negative 2 cosecant squared 2x. And now if we substitute everything in, we will find out that we would get limit, well, actually we don't need limit anymore. We will just get, well, obviously we know the answer, but it would be 2 over negative 2, which is equal to negative 1. And now we know that ln y is equal to negative 1, or y is equal to e to the negative 1, which is, of course, 1 over e. And that, again, is the answer. In a practical sense, I definitely like approach 2 more. But again, I did this video just so I can look at the first identity we proved, which I found was very interesting because I never knew about that. So yeah, this was a neat little video, classic Instagram problem, and yeah, so again, it's not an integral, it's a limit. That's my mistake, but it would, complex. It kind of seems a little complex. Tangent raised to the tangent 2x, but it has a neat solution. So it's always fun when you do a limit like that. But that's all. So thanks, and I'll see you later.